Everyone, we just want to build on the idea of range that you just did with your discovery activity and talk quickly about the different types of continuity. Okay, so a graph is continuous at a point if it does not come apart. Okay, so when it's continuous, there are no breaks in the graph. So that means that you don't have to pick up your pencil when you are tracing the function. Okay. Removable happens if a single point would make the graph continuous. Okay, so that means that when you're tracing the function, you would have to pick up your pencil, okay, over one single point. Jump is when you would need an entire line segment to make it continuous. And infinite is when you would need an infinite line to make it continuous. So the difference between jump and infinite: jump, it has a finite start and end point to the line segment that you would need to complete the graph. An infinite discontinuity, okay, needs a line that's going to go on forever in order to make it continuous. So we can look at the graphical representation of what those situations look like, and then we'll talk about, well, algebraically, how do you get those in a function? Okay, so top left, that is continuous everywhere because I can trace that entire function and not have to pick up my pencil. Okay, top right, when I trace that function, you see that whole makes for one singular ordered pair that I have to skip over. So that is actually removable. Okay, this graph in the middle, that would be the infinite discontinuity because you can see I need an infinite line there to complete this graph to make it continuous. Okay, and then lastly, jump, because the space in between the open and the closed circle, I would need a line segment to go in there to make this continuous. Okay, so algebraically, these are the situations that we're looking for in the function that create each of those types of discontinuity. So if you create a hole in the function, meaning that you cancel something from the rational function, you have a removable discontinuity. Okay, when there's a vertical asymptote, so that's when the denominator is undefined, that accounts for the infinite discontinuity. And a piecewise function is what's going to cause a jump. Okay, because remember, piecewise is separate functions, and when you graph each of those sections on a coordinate plane, the pieces may not overlap, and so you would need a line segment to connect the graph. Okay, so we want to identify our types of continuity. So I'm looking at this first function, okay, and this is going to be an infinite discontinuity because in my denominator, x equals 1, okay, is going to make this undefined. So on the graph, you would have a vertical asymptote, which means you would have to jump over that value. Okay, you would have to skip that value in your domain, and therefore you could not graph the entire function without picking up your pencil. Okay, if we look at number 2, a square root function, okay, we know that in the domain, we would have to limit this to just be positive numbers. Okay, however, if you think about the graph of a square root function, okay, aside from the domain limitations, you could graph that entire function without picking up your pencil. So continuity does not refer to there being a limitation to the domain. It's just, is there a break right in the middle of the domain, which there is not. So number 2 is actually continuous. Okay, and then lastly, example number 3, well, this is a rational function, so we know that we should factor and simplify wherever possible. Okay, now looking at it this way, you may think, oh, there's going to be a vertical asymptote, so this is infinite. However, that x plus 3 cancels out, and we're actually creating a hole. Okay, so remember that a hole accounts for a removable discontinuity. Okay, now there are some situations where you could have multiple types. It could be infinite as well as removable. Okay, it could be jump as well as infinite. These just happen to have one each. Okay, so those are your different types of continuity.